For billions of years, the solar system has kept its oldest secrets hidden among the planets and asteroids. While scientists have studied Mars, Jupiter, and Saturn for decades, there are still regions in space that remain completely unexplored. One of those mysterious regions lies near Jupiter, home to a strange collection of asteroids known as the Trojan Asteroids. According to NASA, these objects are like time capsules, untouched remnants from the earliest days of the solar system, more than 4 billion years old. They move in two vast swarms, one ahead of Jupiter in its orbit and one trailing behind it, locked in a delicate gravitational dance with the giant planet. To understand how our solar system was born, NASA launched a mission unlike any before it, Lucy. This spacecraft's goal is not to land, not to collect samples, but to travel farther and longer than almost any previous mission, visiting multiple asteroids in a single journey. Named after the famous human ancestor, Lucy, whose discovery helped scientists understand human evolution, this spacecraft aims to uncover the origins of our planetary family. Just as the fossilized bones of Lucy revealed humanity's past, NASA's Lucy will reveal the fossil history of our solar system. Before we continue, don't forget to subscribe and leave a like if you enjoy learning about the mysteries of space. Your support helps us bring you more stories from NASA's greatest missions. Lucy's mission is one of the most ambitious space journeys NASA has ever attempted. Launched on October 16, 2021, from Cape Canaveral aboard an Atlas V's rocket, Lucy is set to travel nearly 6 billion kilometers over 12 years, looping around the inner solar system before reaching Jupiter's orbit. The spacecraft will first make two close flybys of Earth, using our planet's gravity as a slingshot to gain the speed it needs. This maneuver will propel Lucy toward the Greek camp, the first group of Trojan asteroids leading Jupiter in its orbit. After studying several asteroids there, Lucy will swing back toward Earth again for another gravity assist, a clever way to save fuel while extending its reach deeper into space. From there, the spacecraft will continue toward the Trojan camp, the second group trailing behind Jupiter. By the end of its journey, Lucy will have visited a total of 8 asteroids, 1 in the main asteroid belt and 7 Trojans. Each encounter will provide a new glimpse into the ancient materials that formed planets, moons, and possibly even the ingredients of life itself. This intricate path through space has been compared to threading a cosmic needle. Every maneuver must be precise, every calculation exact. A single mistake could mean missing an asteroid by thousands of kilometers. Lucy isn't just another spacecraft, and it's a masterclass in efficient, long-duration engineering. Built by Lockheed Martin and managed by NASA's Goddard Space Flight Center, Lucy was designed to operate far from the sun, where sunlight is weak and communication delays can stretch for tens of minutes. To survive and function at such distances, Lucy carries 2 massive solar arrays, each over 7 meters wide when fully deployed. These circular panels give it a wingspan longer than a city bus and allow it to generate power even in the dim sunlight near Jupiter. Because of this unique design, Lucy can travel farther than any previous solar-powered spacecraft. At its heart, Lucy's navigation and science package include high-resolution cameras and spectrometers that will analyze the composition, color, and surface texture of each asteroid. Instruments like the L'Ralph spectrometer and Le Lori imager will help determine what minerals and organic materials the Trojans are made of. A key feature of the mission is autonomous targeting. Lucy must track, photograph, and collect data on fast-moving asteroids while racing past them at speeds over 24,000 miles per hour, 39,000 kilometers per hour. There's no time for real-time commands from Earth. Every flyby will last only a few hours, yet those hours will reveal data that scientists could analyze for decades. Lucy is, in many ways, a robot archaeologist, built not to bring back samples, but to bring back stories written in rock and ice. The Trojan asteroids are among the most mysterious and ancient objects in our solar system. They orbit the Sun at the same distance as Jupiter, grouped around 2 stable regions known as the L4 and L5 Lagrange points. one leading ahead of Jupiter, the other trailing behind. These zones act like gravitational pockets, where asteroids have been trapped for over 4 billion years. Scientists believe these Trojans are fossils from the early solar system, leftovers from the chaotic time when the giant planets, Jupiter, Saturn, Uranus, and Neptune, migrated to their current orbits. They may contain unaltered material from the era when the sun was young and the planets were still forming. Studying them is like opening a cosmic time capsule, giving us clues about how Earth and its neighbors came to be. Unlike the asteroids in the main belt between Mars and Jupiter, Trojans are chemically diverse. Some are dark and carbon-rich, while others are coated in organic compounds or icy materials. This suggests they might have originated in different regions of the solar system before being captured by Jupiter's gravity. Lucy's journey through these Trojan clusters will provide the first-ever close-up look at these ancient worlds. By comparing their colors, shapes, and compositions, scientists hope to understand how the early solar system mixed and evolved. In essence, each Trojan may tell a different part of the same origin story, the story of how our planetary neighborhood was born. Lucy's mission isn't a quick visit. It's a 12-year odyssey across the solar system. Launched from Cape Canaveral in October 2021, the spacecraft's path is one of the most complex ever designed by NASA. Instead of flying straight to Jupiter, Lucy will use Earth's gravity multiple times to slingshot itself farther and faster into deep space. The journey begins with 2 Earth flybys, the first in 2022 and the second in 2024, to gain the speed needed to reach its first destination, the Donald Johanson asteroid in the main belt. This asteroid is named after the discoverer of the famous Lucy fossil, symbolically connecting Earth's ancient history to that of the solar system. After that, Lucy will head toward Jupiter's L4 Trojan cluster, where it will encounter Euripides, Polymele, Lucas, and Orus between 2027 and 2028. Each of these asteroids tells a different chapter of the solar system's story, some dark and primitive, others reflective and bright. But Lucy's mission doesn't end there. After its first round of Trojan visits, the spacecraft will perform yet another Earth flyby, using our planet's pull to redirect itself toward the L5 cluster, the trailing group of Trojans. In 2033, Lucy will finally meet the Patroclus-Mennoetius binary system, 2 asteroids orbiting each other in a delicate gravitational dance. This entire route covers nearly 4 billion miles, 6.4 billion kilometers, making Lucy's trajectory a masterpiece of orbital engineering. If all goes well, by the end of its journey, Lucy will have explored more asteroids than any spacecraft in history, all without landing on a single one. How can a spacecraft millions of miles away study ancient rocks floating near Jupiter? Lucy carries a suite of high-tech instruments designed to do just that, to read the stories written on the surfaces of the Trojan asteroids. At the heart of Lucy's mission are 3 main scientific tools. LaRalph, a color imaging and infrared spectrometer that reveals what each asteroid is made of, whether it's covered in ice, carbon-rich material, or metallic compounds. LaLaurie, a high-resolution camera that captures the asteroid's surfaces in sharp detail, down to their smallest craters and ridges. LTES, a thermal emission spectrometer that measures how these bodies absorb and release heat, offering clues about their structure and history. By combining data from these instruments, scientists can uncover how the Trojan asteroids formed, what they're made of, and how they've changed over billions of years. The goal is to look back in time, to the first 10 million years after the solar system formed, when planets were still gathering dust and debris into their current shapes. Lucy's approach is purely observational. It won't land or drill, but it will provide a treasure trove of information about the building blocks of the outer solar system. Each flyby will last only a few hours, but the data it collects could reshape our understanding of how Earth and its neighbors came to be. In a way, Lucy isn't just exploring asteroids. It's uncovering our cosmic family's origin story, one orbit at a time. When Lucy completes its long journey, it won't just be another spacecraft drifting in space. It will be a time capsule of discovery, forever orbiting between worlds. NASA expects Lucy's trajectory to remain stable for millions of years, meaning it could keep traveling through the solar system long after humanity itself has changed. But Lucy's true legacy lies in what it teaches us. By studying the Trojan asteroids, scientists will gain insight into the formation of the outer planets, the distribution of water and organic materials, and even the origins of life on Earth. These asteroids are like untouched fossils, leftovers from the birth of the solar system. Understanding them could reveal how chaos turned into order, and how a swirling disk of dust became the system of planets we call home. Lucy also represents a new era of efficient, long-duration missions. With its solar-powered systems, the largest ever used beyond Mars, Lucy proves that human engineering can push the limits of where solar energy can take us. This technology could shape future missions to Jupiter's moons, the asteroid belt, or even interstellar space. In the end, Lucy's story is one of curiosity and endurance. Just as the fossil Lucy on Earth helped us understand where humanity came from, NASA's Lucy will help us learn where our world came from. One small spacecraft, tracing the paths of ancient asteroids, may hold the answers to the oldest question of all: where did we begin? As Lucy continues its voyage across the vastness of space, it becomes more than a mission. It becomes a symbol of human curiosity. It's a reminder that even in an age of artificial intelligence and instant information, we are still explorers at heart, reaching into the unknown just to understand where we came from. By the 2030s, Lucy will have visited more worlds than any other mission in history. 8 asteroids spread across nearly 4 billion miles. Each one will tell a different chapter of the same story: how gravity, dust, and time sculpted the solar system we see today. The spacecraft will send back images and data that no human eye has ever seen. Silent messengers from the dawn of creation. Even after its instruments fall silent, Lucy will keep orbiting the sun, a metallic fossil moving among the ancient stones it once studied. Future civilizations might rediscover it and wonder who built this strange relic, just as we now study the asteroids to learn about our cosmic past. And that's the beauty of it. Exploration never truly ends. Every mission, every discovery is a bridge to something greater. Lucy may be powered by solar energy, but what really drives it is the same force that's always driven humanity: our need to know what's out there. Because in the end, the quest to understand the universe is really a quest to understand ourselves.